What have I done now?
Welcome back, everybody. It's probably been about a week and a half since I've filmed the last episode of this creation build, and I've been tinkering. I think there's been a couple weekends in there, so last week was pretty busy here at the warehouse and some other stuff going on, so I didn't get a lot of time to focus on this here at work, but I did have 2 weekends where I tinkered with this late into the night. And let me show you what we have. Okay, so this is where we left off exactly. We solved most of the dimensional issues, I believe. I was pretty happy with this, but the more I looked at it, I didn't like the idea of having these extra bolts in there. It just it didn't. I don't find it visually appealing. So there was another thing I was having where, let me turn this off. This cavity here that I had created, let's just isolate this so we can see better. Okay, so this strange cavity shape here I have going down in there was a little bit of an extreme angle to machine comfortably uh, based on, I showed you guys, I think, the tombstone. It's a four-sided tombstone, which I can hold 4 parts, either 4 identical parts or 4 different parts for the machining process. And what ended up happening there was I was going in at such a steep angle that I was interfering with my ability to place a part on one of the adjacent sides of the tombstone. And because I'm still new to a lot of the fourth axis stuff, I was not getting the tool paths generated that I wanted to do. So at that point, I just stared at it for a while, trying to figure out what I could do to alleviate the issues that I came across. And well, I went a little bit crazy. What I ended up doing was redesigning the entire machine. Now, everything is virtually the same. I made a couple changes that solve those 2 issues. So let me show you what I did. I came over. I'm also, just so you can see here, I'm kind of wrestling with the idea of machine name Simplicity. I don't know if I love that idea yet or not, but something that popped in my head. So that may or may not be the name of this machine. Okay, so if we kind of go back and forth here, you can see everything is virtually identical. Same cam, same everything. Um, very, very close to the same exterior body shape, except for I have this new cover. And this cover is, let's see, that is a subcomponent of the body. And I also went about building this in a more proper fashion where each part is its own entity, and each one of these parts is dragged into this assembly, and you can see these little link icons. So each one of these is linked. So if I make any changes in any of these individual components, they will be reflected in the assembly, and vice versa. I can in fact go in here and I can edit any of these in place, and that will change the master file off on the left side. It's just as long as I save. Anyway, so what I have done here, it's kind of hard to see, but I've got this little groove down in here. I don't know if you can make it out, but it's a recess. It's a little slot, and basically it might be easier to show you the, can we isolate the cover? We gotta isolate the body, and then turn off that. Okay, so now you can see the cover here. So these little tabs, as we'll call them, or extensions, they're going to guide the cover down into the motor or housing or the body. I think I'm calling it just a body now. So that's going to slide it down, and that's going to hold the lower part of the cover in position, and then the whole thing can be retained with just one single screw at the top. So that is, in my eyes, just simpler. Less moving parts, less things to buy, less things to machine, whatever. So, and also, I don't know if you're going to be able to see this terribly well here, but this slot here, the wall thickness on the cover is a little thicker. I increased that, and I created this slot that runs around the pretty much the perimeter of the motor. Let's see if I can, I'll pop the motor on there and just show it to you from the back side. So that slot is just on the inside edge of the motor. It extends outward just a little bit, and what I'm going to do with that slot is I'm going to buy some O-ring material. You can buy that just extruded round rubber, I don't want to say tubing, rod, but it's obviously flexible. So, and I'm going to buy that and cut that to length. I can't do a complete one all the way around because we have the push rod bar and the push rod moving up and down, so that would interfere with that. But what I'm getting is I'm going to cut that to length, press fit into this slot with the O-ring material sticking out the face of that, just a few thousandths, probably 5 thousandths, 8 thousandths, in that neighborhood. I can't remember the exact depth. This will probably change once I get the part made, but I have right now set that to 0.9 millimeters deep. I'm going to buy 1 millimeter material, so that's going to leave 0.1 millimeters of O-ring material sticking up out of the housing. Okay, and that's going to press directly on the face of the motor, and that's 0.1 millimeters, about 4 thousandths, so roughly a thickness of a sheet of paper, and that will compress as the screw is tightened down in the upper hole. So that is going to stabilize the motor within the housing now. The motor cannot rotate due to the tab feature that we had put into the housing or the body itself. These little risers not only hold the motor up off the back of the housing, but they also interact directly with these little recesses in the back of the motor. So that will keep those tabs will keep the motor spaced off the back of the housing, keep it from rotating, and then the O-ring gasket pressing on the front of it's going to hold it in place, completely stationary. So without any additional fasteners, screws, or bolts or anything to hold the motor down, all those problems are solved. I've isolated that in time and space right there, and it cannot, theoretically should not move. And I can adjust the pressure on the motor by just changing the depth of that O-ring slot. So that's it. I did make some changes while I was not recording because I was home and I don't have this whole recording set up at the house. So, but yeah, so hopefully you guys like what you see here. I think it looks just a little cleaner, a little more streamlined, and a little easier to manufacture. Actually, let's look at this one more time without the cover on. And you can kind of see I went with a simpler feature here for the clearance for the push rod mount and push rod to go down. And all I've got to do now is hold that. This face here is 45 degrees between the vertical and the horizontal faces. So 45 degrees is an easy angle to access without creating too much problem with the tombstone setting. So that's how I resolved that. And let's see. Isolate all, everything's back on, covers on. Let's look at the side view and turn on the analysis. And you can see that that 45 degree angle slot here, because I have a 45 degree angle bent into the push bar, is fine. And the cam in its fully downward stroke leaves me probably a good millimeter and a half of, or maybe more than that, closer to 2 millimeters vertical clearance. So there's no chance of anything hitting binding on that. And let's see from the, what's the other sectional view I have? From the front, yeah, you're not really going to get it. A good look at that, but I can just quickly create another sectional view based on that feature, and that's a pretty good look there. So the bar, even when it's far off to the side over here, it's going to have plenty of clearance coming down at this angle and this angle, and should be just fine. So that's what I've done. I've made a few modifications, but all the mechanics are basically the same as where we stood. Everything I've done is mostly visual, other than the slotting mechanism to retain the lower part of the housing or the cover, instead of having all the additional bolts and holes to drill and tap and parts to purchase and lose and more things to go wrong. I like things done simply. So now, let's take you into the next step. All right, so I started mocking up some of the stuff before, but this is where I'm at this point in time. Strategically planning to machine all 5 machined components for this machine in one setup on the new 4th axis rotary and tombstone. In order to do that, this only has 4 sides and we have 5 parts we have to make. Well, 6 parts because the pusher bar needs to be made, but that's not really a machined part other than the threading or the press fitting or however I want to attach those down the road. But that is really buying 1.5 millimeter rod in a hardened state, and that's going to be done with a small tool that I'm actually going to build to put the proper angles and cut to length. So those are all identical, and I may have to make a couple different lengths of those based on different manufacturers of tubes, but I may or may not. I may just support my own tubes and products, and then that's that. If people put up a big stink, then I may make another length of pusher bar. But my job is to work around the things I manufacture and some industry standards, but not to bend to other people's or other manufacturers' wishes. Anyway, so this is what I've done. I've actually removed one of the dovetail vices from one side of the tombstone. That's easy enough to do. Let's see, go into the design phase here. And what I've done here is I've built this component here. I haven't built it yet. I've designed it. These are some little clamps, super powerful, strong little clamps called pit bulls, made by a company called Mighty Bite. I've been using their various products for years, and what you see here is a downward force, and it basically compounds the angular, uses leverage to put into the part that's being held. It has a knife edge. It's actually going to dig into the material that I'm holding. Basically, I will maybe put in a couple dowel pins to indicate these, because I think I'm going to use 3/4 inch material on these. But I don't really need to, because these faces on these pit bulls are 3/4 of an inch, so can quickly indicate raw material in there, close enough for government work. The way I plan on cutting those, it's not going to make a big difference whether it's 10 thousandths off one way or the other, or more, because I'm going to be cutting out of the center of the material anyways. So anyways, so that's what we've done there. Turn everything back on, and you can see I've created the various raw stocks that I need, the right sizes for each component. I have them spaced off of the dovetails far enough so I can machine all the way around them without cutting into my fixtures. A couple of these are turned off, so you just see a part hovering in the area. But if you could just picture another block like this, a little shorter over here, and that's what you get there. You've already seen what I was kind of doing in the last video with the block for the body, which is the most complex part of everything. And then this will hold the brass raw material for the cam and the aluminum raw material for the push bar mount. So basically, I will set up all 5 components on the tombstone, and in a 2-jaw vise next to that, I will set up, I'll make some soft jaws that will hold the 3 blocks of aluminum that I'm going to use for the body, the cover, and the collet nut. And over here, so those 3 components will be held vertically, and every time I press go to start a cycle on the machine, the tooling will come in. It will cut the dovetails on the raw blocks so that those parts will be ready to go into the dovetail feature on the next cycle. And then the raw material that is in the dovetail, each one of those will be completed, all machining operations completed on those features in that one cycle. So every time the operator opens the door of the CNC, first thing they're going to do is snap off each of these components off of the tabs and the arms that we have left in there. There'll be tabs on the smaller components too. Positioning these tabs in such a way where they're going to be so minimal that it's not even going to require another machining process after this is done, because all of my tabs are going to be done on flat surfaces. Basically, next to the machining center, we're going to have a piece of perfectly flat glass and a very fine emery paper, because I'm only going to have a few thousandths of an inch of material, just holding the flat surface on that emery paper and very gently sliding it around and looking at it until it's smooth down to the basic flat surface. And then those parts will be completely ready to go into the vibratory tumbler, tumbled, sent out for anodizing, and eventually assembled as a machine. But what I like about doing it this way is every time the machine runs and shuts off, there's enough components other than the actual bending of the pusher bar to assemble a complete machine. I'm just sort of guesstimating the run cycle time to be about an hour-ish. Could be less if I really get into detailing the the operations and optimizing those for best speeds and feeds, which I will do to some degree, but I'm not going to worry about saving 1 to 2 minutes on a cycle time. I'd rather just ensure better tool life and less stress and wear on everything involved. So, but let me show you now a little bit of what I was talking about here. It's the best way to look at this. Let's get this roughly at 45 degrees here. Okay, that's approximately 45 degrees. Let's open up this first operation, and I believe this is it. Yeah, this is the tricky one. I've actually I've had to order some special tool holders. I've just placed an order for a few more $1,000 worth of special tool holders and very special tools to be able to make these components all in one shot. So special cutters, undercutters, reverse radius, like underside radius, and kind of specialized stuff. But you can kind of see here that this tool, when it comes down to cut out that 45-degree pocket, that relief I was talking about for the cam action, 45 degrees is about the maximum angle. It is the maximum angle that I can come in and not interfere with parts that would be on this tombstone. In fact, if I was still using the original tombstone, it's actually a little taller than that, and the parts would be extended up even higher, so therefore that wouldn't be possible at all. And I would only be able to hold one part, seeing how it's, if the parts were made of the same material, I could cut 2 parts out of 1 block of aluminum there. But I want the cams to be brass. So they get a little more inertia, I think, when they're swinging, and they have a little bit more of a dampening effect on impact, which kind of reduces the impact to the bearings and the motors and things like that. So, but you can see this is a tool that I physically already have, which would be a 4-inch length tool holder. And then I think I'm using a very extended 2-inch length stick out on this tool, and that's not enough to reach that pocket and machine it properly. In fact, I can simulate that here quickly. Let's see. There we go. It's generating. Okay, so let me turn the speed down slower here. And you can see this tool's going to come down, and it's going to, it would be physically hitting the other parts. And this is even with the fixture that I made, which is a lower height than the traditional fixtures. So what I needed to do is instead of getting 4-inch extended tool holders, I ordered some 6-inch extended tool holders, which raises this part of this, the base of the tool holder up 2 more inches, and that will get me adequate clearance to get in here. But you can see when this tool holder comes down, this is really just a few millimeters, maybe 4 or 5 millimeters top. So it's less than 1/4 of an inch, probably 3/16 of an inch between this tool holder and this fixture that I made to hold these parts. And, that's one of the reasons I actually machined in this 45-degree chamfer on the face of this, this mini vise that I'm making, is for clearance, because other than that, it just physically would not work. What I would end up doing is having to not use that side of the tombstone, and that's kind of ridiculous, because it just, it just doesn't make sense. Why would I not utilize items that I've purchased? So that is how that goes. So let's just quickly get into I'll give you a quick simulation of, actually, I think it'll be fine detail, but you can see I got locks on all these operations because I didn't want them to change because I've got it pretty much where I want it. Get a good viewing angle here, maybe. Okay. And you're going to have to understand that in the real world, this whole tombstone would be rotating back and forth to change angles, but the simulator just makes the tool move around the part, which is only half true. It will move up and down, but the table itself will move forwards, backwards, left, right, and rotate. So it's just strange that it simulates it that way. So, okay, so let me speed this up a little bit. If not, it takes quite a while to produce here. And this is pretty much the actual tool paths that I've programmed up to this point. And it's a lot of fun to watch this, to be honest with you. Because you think about these things in your head and you're like, all right, I can visualize this, but to get the visual confirmation from the simulation is always exciting. All right, I'm going to flip the part over a little bit because it's going to start to cut from the other side here in a second. And again, the whole tombstone would have rotated 180 degrees and moved further back in the machine so that it could cut from the other side. I'm going to change there, we'll make it look like it's cutting right out of the aluminum there so you can get a little bit more accurate representation as to the finish on the part as it comes off of the machine. And I'll speed that up just a little bit more. Okay, you can see after the first operations, we've got a tab on the one side, a tab on the other side, and because I used a large tool, it couldn't cut behind here. So it leaves an involuntary, well, I can't say involuntary, it was a planned third tab in the bottom that will be removed during these operations next. So now because I'm removing most material from the other side, you can see I've thinned down that tab, but I'm going to leave that little bit on there until we're virtually down to nothing left to be removed from the other side. Okay, so these operations will be coming in, working the end, cutting the threads, chamfers, all of that. And okay, so now our third tab has been machined off the front. So for the rest of this, I'm taking really, really, really tiny cuts, thin depths of cuts, and really going to just do the finished contouring on the machine. Here we're working with, you can see let's see if I can stop it. You can see the end of the tool is round here. It is a ball-nosed end mill, and this is what's going to be used for the final. Ooh, all right. There we go. So this is what's going to be used for the final contours on the machine. And, the simulation leaves a little bit of a, little what they're called cusps. But they're going to be barely visible to the naked eye. And once the machines come out of the vibratory tumbler, there will be nothing left. If there is, then I will change my tool path so that the tool laps or tool paths are offset by a smaller amount, leaving smaller cusps so that it does come out better in the finished assembly. But let's see here. What is this? Oh, and then the very last operation in this is I come down and I'm going to back this up just a tiny bit. Okay, you can see these tabs are pretty thick and healthy here at the very, very end. And there's a tiny tool that comes in. It just removes the tiniest bit of material out of these corners. That's its only job. But after all of the material's been removed, the last operation I'm using is a bigger tool to come in and take these relatively, I won't say thick, they're about a 1/16 of an inch, no, about a millimeter actually, about 40 thousandths of an inch right now, but that's more than enough to stabilize this for the light cuts I was taking. And then what I do here with the last tool, you see I come in and I just cut those down to paper thin. That is non-existent. That's thinner than a sheet of paper, but it keeps the part from falling off or moving, or if one side dropped, deflecting into the tool, creating a bigger problem. So it just holds the part onto this mount, I guess we'll call it, and that will stay suspended in there, and that will just continue to ride around on the tombstone while the operations for the other parts are completed. And that's that. So when it all stops, operator reach in, grab that body, snap it off, grab the collet, not snap it off, grab the cover, snap it off, snap off the cam and the mount, load the blank chunks from the dual jaw vise on the left into the tombstone, a couple small blanks of aluminum and brass into the mini vices there, and press go. And after he presses go, he will then turn around and do a little bit of light sanding on the faces to remove the remaining tabs off of the finished parts, and then they're ready to go into the mass finishing machine and all eventually off to anodizing. So that's where I'm at. I hope you like the new version of the machine, and yeah, I appreciate you all joining me on this journey. If you like what I'm doing, remember to hit the subscribe to the channel. YouTube really loves the thumbs up for some reason. I don't know why, but it makes their algorithm go get all like, schoolgirl giddy. And share these videos with your friends. Thanks for watching. So what do you think? Did I make it better? Did I make it worse? You tell me in the comments below.